Very good morning, my dear students. We know this is the most difficult situation, both of us, whether students or teachers, because of the lockdown is extended day by day. Our daily activities are changed step by step, whether it's good or bad, depends upon our attitude. So don't hesitate this in the situations because we know that the lights comes out from after a dark room or dark light, so we can spread around us a positive attitude, so avoiding the negative thoughts. I hope you it may be some of are utilizing our online classes very skillful and asking some doubt, and few of them busy with their contents like using mobile phones, but asking frequently to the parents, I am studying in online classes, but they are not fulfill our assignments. So simply tells us don't waste your times because of time is more precious. Once is forgot, not in forgot, once is passed on, it's never come back. So uh, use your time properly because of this is the situation how to overcome this covid-19. So nothing to tell us to gaining your knowledge, to study the online classes daily. Thank you. Now we can derive the macroscopic form of Ohm's law from its microscopic form. In last class we can derive the formula of microscopic of Ohm's law. We can derive J equal to sigma E, whereas J is called as current density and sigma is called as conductivity of a material, and E is the electric field. Okay, see the diagram. Consider a wire. This is a segment of a wire, and the length of the wire is L and the cross sectional area A. When the potential difference V is connected across the two ends of the wire, when the current flows from positive terminal, which means the terminal positive terminal to negative terminal, so the current flow, the direction is indicated by like this. Okay, now we assume the electric field in the uniform entire the length of the wire, so the potential difference we can write as V equal to EL. This formula comes from, already we can derive from the relationship between potential difference and electric field, dV equal to minus of EDX, so E equal to dV by dx. This formula. As we know, the magnitude of the current density J equal to sigma E. Because of last class, we can derive this form of microscopic form, J equal to sigma E. So in these equations we get E value, whereas E equal to V by L. So substitute the value of E to these equations J. So J equal to sigma, then after E equal to V by L. So we get, already we know that current density is defined as current per unit cross section area. So compared to the equations, this one and this one, both our left hand side will be same, so we can compare the right side. Here I by A, and this equations we get sigma V by L. By rearranging these equations we know the value of we get the value of V. So V equal to IL by sigma E. In these equations, L by sigma E equal to called as resistance of the conductor, whereas R equal to L by sigma E. This is the resistance of the conductor. Therefore, the macroscopic form of Ohm's law can be stated as, we can write as V equal to V, then after I equal to I, L by sigma E called as R. So, V equal to IR. This is the macroscopic form of Ohm's law. Then, what do you mean by resistance? Or called as state the or define the resistance. In this equation 2.17, we can tell us very easily to compare these equations and state the definitions. The resistance is defined as the ratio between potential difference across the given conductor to the current passing through the conductor. So R equal to V by I. So they know that a unit of resistance is called as ohm. So the unit will be called as ohm. Next, we draw the graph between current and voltage. So the graph tells us the slope, which means the slope which is equivalent to the inverse of the resistance, or it shows us the resistance of the conductor. So first of all, we take as the voltage in x-axis and current is in y-axis. To draw a line which means a linear line, a straight line, and find out the slope. The slope value will be same at all the points, which means the slope which is equivalent to the reciprocal value of the resistance of the conductor. The slope tells us those materials where the current against voltage, the graph is in a straight line through the origin said to be a obey of Ohm's law, and the behavior is said to be ohmic. This is the first diagram shows. And second one, the materials or devices that do not follow Ohm's law are said to be non-ohmic. In this first diagram follows Ohm's law, so called as ohmic. In second diagram does not follow Ohm's law, said to be a non-ohmic. These materials have more complex relationships between voltage and current. So we plot a graph between voltage and current. The ohmic material is non-linear. The ohmic material is linear. In this diagram, the non-ohmic material is non-linear. So both of the relationship tells us the two diagrams, diagram A and diagram B. In next topic, resistivity. In previous section we have see about the content of resistance, whereas resistance is directly proportional to the length of the conductor and inversely proportional to the cross section area, whereas sigma is the conductivity of the material. So R equal to L by sigma E. We know that we can write as R equal to 1 by sigma into L by E. Here the reciprocal value of the conductivity, is called as specific resistance rho, whereas rho equal to 1 by sigma. So the resistivity rho equal to 1 by sigma, so we can write as 1 by sigma as rho. So we can rewrite as R equal to 1 by sigma equal to rho. So rho L by A. So resistance R equal to rho L by A in these equations. So we can tell us the resistivity of the material which is equal to the reciprocal value of the conductivity. So in this equations to substitute to R, so R equal to 1 by sigma equal to rho, so L remains L by E. So the resistance R is directly proportional to the product of the length of the conductor, and resistance R is inversely proportional to the cross section area of the conductor, whereas rho is the proportionality constant or called as specific resistance or resistivity. So rho, then we can derive as the unit of rho. So we can know the unit of specific resistance, rho equal to, we can write as RE by L. We know R is called as resistance. The unit of resistance is ohm. Area, the unit of area is meter square divided by length of the conductor. So length we can measure the unit of meter. So meter can be neglected. So the unit of specific resistance is ohm meter. So finally we can define what do you mean by resistivity. So rho equal to RA by L. If the length of the conductor taken as L equal to 1 meter, in cross section area A equal to taken as 1 meter square. So we can measure or tells us the resistivity in terms of volts. The resistivity is defined as, the bold letters will be provided. What do you mean by resistivity or specific resistance? The specific resistance or electrical resistivity of a material is defined as the resistance offered to the current flow by a conductor of unit length having unit cross section area. This is called as specific resistance. So the specific resistance are classified in 3 types based on resistivity. So see the tabular column. Resistivity varies from the materials. It tells us there are 3 condenses here: the insulators, semiconductors, and conductors. Finally, the conductors having a lowest resistivity and insulators having a highest resistivity, and between of semiconductors having a resistivity greater than conductor and less than insulators, in between of conductors and insulators. Another one more task, mostly called it will be asked frequently. One more questions. The human body contains a large amount of water. We know our body contains a large amount of water, which has low resistance around 200 ohm, and the dry skin. Mostly the persons will be differentiated with the organs of some other persons will be having a dry skin, some persons having oily skins. In this content, the low resistance around of 200 ohm and the dry skin has high resistance of around 500 kilo ohm. Clearly notice this: low resistance around 200 ohm, and the human body, it means human being having dry skin. Those persons will be having or occurring of dry skin. They are occurs of high resistance around 500 kilo ohm. When the skin is wet, the resistance is reduced to around 1000 ohm. This is the reason repairing the electrical connections with the wet skin is always dangerous. Next, what we are going to see about the next content of resistors connected in the combinations of series and parallel. Here, the electric circuit, this is the electric circuit. The electric circuit may contain number of resistors which can be connected in different ways. In this process, the resistors will be connected by the process of series. How they are connected in series? Let me see. First, the resistors connected in the combinations of series. Look at the diagram. When the two or more than two resistors are connected in to in, which means the ends of the resistors R1 connected to the another ends of the resistors R2. So the ends of the resistors R2 is connected to the another ends of the resistor R3. These combinations will be tells as series combinations. The resistors could be simple resistors or bulbs or heating elements or other devices. The figure shows R1, R2, R3 are the three resistors connected in the combinations of series. And the voltage, the potential difference across the voltage, which means battery will be connected in between of the resistors. The amount of charge passing through the resistors. Second diagram. The amount of the charge passing through the resistors R1 must also pass through the resistors R2. Here the charge, whereas here R1 occupying some amount of charges, whatever it is maybe X or Y or Z. The same amount of charges occupy the resistors R2. In the resistors R3 occupy the same charges. The charges cannot accumulate anywhere in the circuit. So the charges cannot accumulate anywhere in the circuit. So the current, due to the reason the current I passing through the resistors, all the three resistors must be same. So simply tells us the current should not changes. Here simply tells us we are connected in three resistors in series combinations. Once we can pass the current I, the resistors R1 in this resistor R2 in this resistor R3. The current passes through the resistors. Here the same amount of current passes I. In this combination the current will be I. In R3 will be occur of I. The three resistors will be occupying of a same amount of current. The current should not changes. So applying Ohm's law. The same amount of current passes through the different resistors of different values, then the potential difference across the each resistors, we know the potential difference according to Ohm's law, V equal to I, or so applying this content, the potential difference of V1 equal to I R1, V2 equal to I R2, because of the current could not changes, V3 equal to I R3. So the finally simply tells us the total voltage of the circuit, which is equivalent to the sum of the individual voltages, which means V1 plus V2 plus V3. It tells us we are right on us, whereas V equal to V1 plus V2 plus V3. So we can write us in this session. So here the total voltage V equal to V1 plus V2 plus V3 equal to, whereas we know that V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So in this three term commonly we are taken out I. So we are taken out I, remaining R1 plus R2 plus R3. So the total voltage V write as V equal to IRS, which means the resistors connected in the combinations of series. So we can put the suffix of the S or. So V equal to IRS, so V equal to IRS, so write as V equal to I or S equal to I into remaining R1 plus R2 plus R3. So we neglect I. So RS equal to R1 plus R2 plus R3. This is the equivalent resistance connected in the combinations of series. So this equation tells us several resistances are connected in the combinations of series. The total or the equivalent resistance which is equivalent to the sum of the individual resistance. The total or equivalent resistance which is equivalent to the sum of the individual resistance. And one more point providing in notes, the value of equivalent resistance the value of equivalent resistance in the series combinations will be greater than the individual resistance. It simply tells us in case of Rs equal to 30 ohm equal to here 10 ohm plus 10 ohm plus 10 ohm, which means the equivalent resistance always greater than the individual resistance. This is in this point. The circuit will be providing here. The circuits will be connected in the combinations of parallel. How they are tells us the resistors are in parallel. When they are connected, the three resistors R1, R2, R3 across same potential, which means the potential does not changes. Here the potential will be same. So the figure will be tells us the resistance connected in the combinations of parallel. In this case, the total current I flows or leaves from the battery split into separate places, like us the current leave out from the voltage, which means battery, this current split into three separate places because of we are taken as three resistors. In this session the current will be passes I1, and here the current will be split into I2, and here the current will be I3 the same way. So the resistors R1 and R2, R3 having different amount of current. Due to this conservation of charge, the total current I is equal to the sum of the individual currents. Here we are taken as the total amount of current which is equivalent to the sum of the individual current I equal to I1 plus I2 plus I3 in this resistors. So the voltage across the resistors is same. The voltage does not changes. Here the voltage will be same through the resistors R1 and R2 and R3. The both are the three the all the three resistors are having same amount of voltage V. So since we are applying the Ohm's law, we know that Ohm's law, whereas Ohm's law V equal to IR, we are derive I equal to V by R. In this case we are split into the current of I1 and I2 and I3, so we can measure the value of I1 and I2 and I3. We can write as I1 equal to V by R1, I2 equal to V by R2. Similarly I3 equal to V by R3. In this case the voltage does not change, so we can put it the voltage will be same in three cases of I1 and I2 and I3. So in this sessions, so finally in this equations tells us the total sum of the current which is equivalent to the sum of the individual current according to the conservation of charge. So finally I equal to V by Rp because of the resistors are connected in the combinations of parallel. So put it in. So we can substitute the all those value of I1, I2, I3 and I in the equations of 2.24, whereas I equal to I1 plus I2 plus I3. So generally we can write as I equal to V by Rp equal to I1 equal to V by R1 plus I2 equal to V by R2 plus I3 equal to V by R3. The three terms commonly will be leaving there V. So taken out common. So V by Rp equal to commonly we are taken in V. So remaining 1 by R1 plus 1 by R2 plus 1 by R3. So neglect the terms of V and V. So remaining we get that 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3, sorry, 1 by R3. This is resistors connected in the combinations of parallel. In this equations tells us here Rp is the equivalent resistance of the parallel combinations. Thus, this equation tells us when the number of resistors connected in the combinations of parallel, the sum of the reciprocal value of resistance of individual resistors is equal to the equivalent resistance, the reciprocal value of the equivalent resistance. And then one more thing, in previous sections we can discuss, which means the resistance in the combinations of series are is always greater than the individual resistance R1, which in this case is series combinations. Here 1 by Rp, the reciprocal value of resistance in parallel combinations, always lesser than the individual resistance of reciprocal value R1. The both cases considered in one more questions. So providing the point will be in our note session. And another one more thing, most of the parallel combinations will be use of household lines, because of in case of there is a power fluctuations will be produces, not even all the devices could not damages. And finally we are discussed about color code for carbon resistors. This is the carbon resistors. Carbon resistors is nothing but it consists of a ceramic core on which thin layer of crystalline carbon is deposited. Why we are using this carbon resistors, or what are the advantages of carbon resistors? The resistors is inexpensive and stable. They are compact in size, a small size. So the value of resistance of indicating according to some rules. This is the color rings. Compare the two carbon resistors. Some colors will be varying. In this carbon resistors will be red, and silver. In this carbon resistors will be yellow, violet, and brown and gold. What are the two carbon resistors will be represent of differentiate of these colors? The first three colored rings will be indicate the value of the resistors. So value of the resistor can be measured by using of the first three colors. The first two rings indicates significant figures of the resistance, and third color will be indicates the decimal multiplier, and fourth ring will be tolerance of the carbon resistors. So simply asking these questions, find the value of the carbon resistance in tolerance. So we know that sequence clearly: black, brown, red, orange, yellow, green, blue, violet, gray, and white, and till stop. This is the color, and this number start begin 0, 1, 2, 3, 4 up to 9. The color will be white. So the color code will be the multiplier: black 1, brown 10 power 1, 10 power 2, 10 power 3 in the sequences. So we can memorize these colors only in underline the first letters. Simply tells us we can memorize some mnemonics. BP, Roy, Great Britain, very good wife. So in the first letters will be or the mnemonics to remember the color sequence. Once again tells us the color sequence will be remember the first colors. The top of in our top of the head will be in the color of black. So first color will be black. Second brown. So brown. BP, Roy, Great Britain, very good wife. So the mnemonics are very easy to remember the color sequences. Once again repeat the BP, Roy, Great Britain, very good wife. Finally, how we can measure the value of the carbon resistors? In the question paper, the color will be provided to this question paper: red, 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 and silver. We know that the first two rings so indicate the significant figures, and third ring will be indicates the multiplier, which means digit multiplier, and fourth ring will be provide the tolerance. Here, the red color, red will be having the numbers of 2. So first two numbers will be decimal multiplier, not in decimal multiplier, significant figures. So 2, then after 2. The third rings indicates multiplier. So we can provide us red color will be 10 power 2. So adding 2 zeros. Adding 2 zeros. And silver, the tolerance. In case of how we can measure the tolerance, brown will be 1%, red will be 2%, gold will be 5%, and silver will be 10%. The fourth ring will be in case of brown, we can write as 1%. Red, we can write as 2%. Gold, we can write as 5%. Silver, we can write as 10%. There is no color. In case of in this ring, there is no colors will be provided to the carbon resistors. We can put in the value of 20%. There is no color, we can put the value of 20%. This is an important one. Okay, good. So silver color, the tolerance will be plus or minus 10%. So we can write as 2200 ohm plus or minus 10%, or 22 into 10 power 2 plus or minus 10%. The another carbon resistance will be providing, and also to measuring the value of the carbon resistance, and the result will be provided here. The yellow color 4, violet 7, then after brown color will be having the power of 10 power 1. So adding the zeros will be only 1. Then after gold, the gold color will be having a tolerance will be 5. So plus or minus 5. So compare these two carbon resistors, we can easily understanding this concept. Thank you.